today. So as always, if you guys have any questions, please feel free to unmute yourself or put it in the chat. So we're going to go ahead and we're doing trig differences identities. So there's trig difference identities, which is going to focus on the subtraction or the differences in them. And then there's also going to be sum identities. So in this piece right here, I went ahead and put a bunch of formulas. These are going to be the sum and differences. So these are all in the sheet. But the next section for the way ours is broken up, the next section will focus on the sum. This section's only going to focus on the difference. So really we're going to be focusing on this piece, and this piece, the difference or the subtraction ones. You could see the similarities between them, so it's kind of why I went ahead and put them together. So if it's sine and it's a sum, then it's a sum in between. Difference, it's a difference in between, though that's different when we talk about cosine. Cosine, they're switched. When it's a sum, it becomes a minus in between and vice versa. So you could see some of the differences. Tangents are obviously the most ugliest looking ones because they put them into division problems, but these are what we call the sum and difference identities, and they're all on that sheet that I put in Google Classroom. The other thing is going to be our co-functions, And so it's basically saying if we add or subtract these values of pi, then we could get these pieces that are going to be equal. So if I take a sine of pi over 2 and I subtract that theta value, it's equal to my cosine. The difference between a sine and a cosine is going to be that value of pi over 2. So just some correlations, so you could see them here. Those are what we call our co-function identities. So when I go back to formulas, I'm talking about these ones today. Just so you know, they're all right there. Again, recommend you print out your formula sheet, and it will say sum and difference identities, which are the ones you're going to want to use for today. Your co-functions we kind of use throughout. So let's go ahead and let's hop into this. Sorry. Okay, so our first one is just basically figuring out the steps. So we are given, and luckily it's a drop-down menu when you guys go through to do this. So we're given cosine of pi over 2 minus some value. So it's cosine of pi over 2 minus some value. And I could go ahead and it's saying, well, what is that? What is that telling me? So if I look here, cosine of pi over 2 minus some value, so cosine pi over 2 minus some value is equal to my sine of theta, or what is that going to be modeling? This is actually what they want you to do as a co-function. So you can see how it models that. It's a co-function identity. And then, I don't like how they did, what are they? So, okay, so they're kind of going above. So the next one here is they're going to be distributing through. And when they distribute this through, so it looks like they have an error right here in regards to, they shouldn't have had the parentheses here. They have the distributive property, but they shouldn't have had this piece here. So just so you know that this parentheses should have been removed. So it should have been written as cosine of pi over 2, and they distributed. So you could see that this became a negative x, but that should be a positive y. They had the parentheses there. That's an error on there. You know that we've come across several errors. Well, then how are they going from here to here? They're having you look at this and see that you can regroup them. You could group it like this, or you could have grouped it in a parentheses here, but then this should have been written as a plus in between. The way that they wrote this, this would make it a negative, and then this would go ahead and put it back to your negative. And so I don't really like how they grouped that, but that's okay. We can work with that. And so we went ahead and we're going to put this as they have it as your associative property. That's just regrouping your parentheses. Your associative is regrouping. The other one that you guys get that mixed up with is commutative. Commutative is something like 3 plus 2 is equal to 2 plus 3, where you're changing the values. That's commutative. Associative is just moving the parentheses. Okay, so then how did they go from our step 4? What happened from here to here? And you can see they factored out that -1. Then what do they do at step 5? So how do they go from here to here, here to here? And this is where things are going to be new to you. Like, well, how did they go from this little thing here to this big old thing? And why would that even be beneficial? Okay, so when I look at this, I notice certain things. It's cosine of two values and I have a minus in between. So when I look at this, this is one term, this is another term. It's a minus in between. So that minus is separating them. When I go up to my formulas, I have cosine and I have something minus something else. I have one term minus another term. It's equal to this whole big old thing. And that's what we're using down here. So this first term is my A, the second term is my B. So this would be that A value, this would be that B. So wherever I see A and B here, I would plug in this whole piece. And that's what they did. So they said that this is equal, this was that A value, this was that B value, plus sine, this was that A value, this was that B value. So this was just plugging it in to my formula right here. That's all they did. So you need to have the formulas. That's not something you have to have memorized. You just need to have the formulas convenient and have access to them. If we were in the classroom, I would give you a formula sheet just like the one I posted up there so that you have it. You don't have to memorize all these formulas. That would just be craziness. So step 5 was what they would say is the cosine, and this is the difference identity. So step 6, how do they go from here to here? Well, I'm looking to see, well, what's different? Well, these pieces are the same. This is the same, and this is the same, right? What's different is this whole piece and this whole piece. And remember that pi over 2 minus something, that's now I've seen it up here, I'm seeing it here. And so those are going to be my co-function identities. So cosine of pi over 2 minus some x, some theta, some value, cosine pi over 2 minus some value is going to be equal to sine. So that's where the sine came from. And very similarly, sine of my pi over 2 minus some theta, some x, some unknown, would be equal to that cosine value. So that's where that came from. So this was my co-function identity. And this last piece, and this is building on some stuff that we've seen back at the end of last semester. So how did I go from cosine of negative y to this value here? And then I went from sine of negative y to sine y, but notice how the sign changed. This is what we call our even and odd identities, our even and odd functions. So we had our cosine function even and our sine function odd. And you'll see that FCN I often use to abbreviate even and odds. Okay, so what were those even and odd functions? So remember, as a quick review, if I have cosine of negative x, that is equal to cosine of x. So the negative can just come out. So if I had cosine of negative 45 degrees, it's just equal to cosine of 45 degrees. I could get rid of that negative. Different though than when I have my sine of negative x, the negative comes out in front and becomes sine of x. Sine and tangent are very similar in that aspect that tangent also comes out in front. So these are what we call our odd functions. These are what we call our this is what we call our even functions. Also remember, talk about the inverses. Cosine, when we find the inverse is quadrants 1 and 2. The inverse for sine and tangents were the same, where it was only 1 and 4. So they were also the same for when we talk about the inverses. So kind of a lot to take in, a lot of different steps, but it's a good little review here. This is review, and then this is using some new pieces. So using these type of problems really helps you kind of see, well, what's happening from step to step. I kind of like that part of it. All right, so my next one says, write the given expression as a single trig function. So as a single, if you notice, I have 1, 2, I have a bunch of different 4 tangent pieces in there, and I want to write it just so it's tangent of one number. I don't want all these other tangents. And so I go, okay, well, I'm obviously going to be working with this information because that's what the unit's on. And I see that it's tangent, and I match it up, and I see that I have a negative and a positive, a negative and a positive. So I can easily match this up to my equation up here. Let me see if I can actually, this isn't very neat over here, but this will keep it handy. It's my kind of cheat sheet here. So here's what I'm matching up to. This is what I'm going to use. So this is my A. This value here is my A. So this 57 is my A. So A represents 57 degrees, right? That's my A there. Then my B, this is my B. My B is this 21. So B is equal to 21. And if I have this, it's equal to, this piece is equal to tangent of A minus B, right? So that has to be equal to then tangent of 57 minus 21. 57 minus 21 then is going to be tangent of 36 degrees. So this whole thing is equal to tangent of 36 degrees. Done. That's what they were looking for. So this is just the instruction today. It's a lot to take in because we haven't really worked with stuff like this. So everything that we're kind of doing going forward is going to be very formula based. If you have the formulas, it's easy, but it gets to be that there's so many formulas, it really overwhelms you guys. So why do I care about those sum and difference formulas? Why would I care? Well, in this case, it says find the exact value. Exact values are going to be values from your unit circle. From our unit circle. When we talk about an exact value, it's going to be from the unit circle. Some of you guys go, but wait, isn't the calculator exact values? No, because if I have the square root of 2 in a calculator, that's irrational, which means it's going to, if I put square root of 2, it's going to give me a value, and it gives me this, and it stops at 2, but it really continues forever, right? So this is a rounded value. It's rounded. It is not exact. Square root of 2 is the exact number. This, although we have all these decimals and we think it's more accurate, it's not because it rounded, because that number goes on forever. So exact values are going to be values from a unit circle. So, okay, so I go to my unit circle. Oh, yes, that unit circle, it's still around. Do you guys want me to resend out a unit circle for this semester? Do you guys still have your old unit circle? Would that be helpful? Put it in Google Classroom.
Yeah, can you send one out, please?
Yes, I will do so. I will definitely do so because I think it'll be handy. You guys are going to want one printed. Keep it handy. So I'm looking for 105 degrees. So I go here and I'm like, wait a second, there's no 105 degrees. How can I find the exact value, something from a unit circle, when it's not there? That's where this idea of using our sum and difference comes into place. So here's how we want to go about this. I want 105 degrees. So there's more than one correct way to go about this, more than one correct way. So I need two values, and we're using differences. So I want to do two values that when I subtract them, they add up to 105. For instance, if I do 150 degrees minus 45, and when I say two values, I want two values that are on the unit circle. I want to pick values that are on my unit circle. So 150, 135, 120, whatever it might be. So I'm going to do 150 minus 45. That is equal to 105 degrees. Is that the only thing that's going to equal 105 degrees? No, there's going to be other combinations. There's definitely going to be other combinations. I could have done 135 degrees minus 30 degrees. That gives me 105. So there are multiple ways to do this, multiple ways to get to this value. This is not the only one, so you need to be aware of that. I could have also done addition. I could have done, let's see, my 60 degrees plus my 45 would also give me 105 degrees, right? All of these are valid ways to do it, all of them. And they're gonna give me the same answer in the end. They're gonna give me equivalent answers in the end. So I just need to pick one of these ways. Now, we're not working with addition right now. That's the next section. So I'm not gonna worry about that one. And for today's purpose, I'm gonna just choose this one just because that's the one I wrote down first. No other reason than that. One isn't better than the other. So choose whatever you come up with, but you're looking for this value and you wanna pick values that are correlate to your unit circle. So here's what happens. I have now that instead of sine of 105, I'm going to do sine of 150 degrees, oops, there we go, minus 45 degrees, right? Because this is just 105, so I'm not changing anything. And from my front side of my paper, I have the equation that sine of A minus B is equal to sine of A cosine of B minus cosine of A sine of B. So that means that this is that A, this is that B value, and I'm going to plug it all in. So it would look like this. So it's going to be equal to sine of 150 cosine of 45 degrees minus cosine of 150 sine of 45 degrees. And then, you know, the stuff that we did with the unit circle last semester, and you guys like, some of you guys might be like, yay, I'm glad we're done with that. No, it's all coming back. We're going to be using a lot of that. So what do I mean by that? Well, I need to figure out what is sine of 150 degrees. So remember, sine of theta is your y value. Cosine of theta is going to be your x. Tangent of theta is going to be y over x. Hopefully that sounds familiar. That information you still need to know. And it's not hard to do. Sine of 150, so I go to 150. Sine is then telling me I'm looking at the y value. So it's just 1/2. Sine of 150 is 1/2. That's it. So then I'm looking for cosine of 45. Cosine of 45, so I go to 45 degrees. Cosine is the x value, so it's going to be the square root of 2 over 2. So cosine of 45 is the square root of 2 over 2. Minus cosine of 150. So 150 cosine is negative square root of 3 over 2. So negative square root of 3 all over 2. And then I do my last piece, which is my sine of 45. So I go to my 45 degrees and I look at the y value because it's sine and it's the square root of 2 over 2. And then I just multiply these two pieces together. So I multiply these together. 1 times square root of 2 is the square root of 2. 2 times 2 is 4 minus, well, this is a negative and a negative, so it's actually going to end up becoming a plus, right? Square root of 3 times the square root of 2 is going to be the square root of 6. 2 times 2 is 4. They have a common denominator. You're going to see that happen all the time. That's going to be the majority of your problems, unless you're starting to use your tangent stuff. Otherwise, you're always going to have the same denominator. So if they have the same denominator, I could write it as one equation. So it'd just be square root of 2 plus the square root of 6 all over 4. And there's your answer right there. Sometimes when you solve these, you might have it as the square root of 6 plus the square root of 2 over 4. That's equivalent. That's totally fine. That's perfectly fine. It doesn't matter which one's first at all. So no, just depending on what numbers you chose, the ordering might be different. That's okay. There was a lot to take in. Do I have questions before I continue to the next problem? All right. So of course, as you guys go through the instruction for this, like they kind of will emphasize some of the background stuff more than I do. I probably spend more time just kind of going over the how to do some of the stuff you should already know, where they just will expect you guys to remember it all. All right. Another type of problem you're going to see that will involve this. So it says you're given that sine of u is this value. So you're given this information. You're given cosine of v. And they want to know what is the exact value of cosine of u minus v. It also gives me this important information that we're in quadrant 3. We're in quadrant 3. So just as a review, quadrant 3, all students take calculus. Remember that? Where this is saying they're all positive in quadrant 2, sine is positive in quadrant 3, tangent is positive, and in quadrant 4, cosine is positive. So again, a little bit of a review. So we're focusing in here in quadrant 3. So tangent's positive, and of course the reciprocal cotangent would be positive. That means that sine and cosine would be negative. So let's kind of go back here so you can see that they're all negative because we're in quadrant 3 for both of them. So here's what I'm looking for. I want to know cosine of u minus v. And according to my formula that's on the other side, the equation, so question is, does the equation I said only work for sine? This equation up here, I believe is what we're talking about, only works for sine of a minus b. That equation only works for sine of a minus b. If we're talking about cosine now, if we're talking about cosine, then I go to my formulas and I look for cosine, and I match it up in a minus b. So this case, I'm using this equation. So my a is just my u, my b is my v. So u, v. So it's going to be totally different formula because this has cosine and cosine together plus, and it's going to have sine and sine together. So this would look like this. So it's going to be cosine of u, cosine of v, plus sine of u, sine of v. So notice totally different equations depending on what you're using. So it's very important that you look at what am I solving and match it up to the right equation. So here's the equation we're going to use. If that's the case, then I need to know what is cosine of u, my cosine of v. Oh, look, I already actually know cosine of v. That was given to me right here. So I know that this is a -4/5. I don't have this cosine of u plus sine of u. I know that's also given to me. So this piece right here is -7/25. What I don't know though is sine of v. I don't know this piece either. So I have some unknown pieces, and that's a problem. So I'm going to say, well, then how do we solve this? So they gave me 2 pieces, but I still have 2 more that I don't know. All right, so now here's where things get complicated for you guys. This is the part where you guys struggle is, okay, I know my sine of u is equal to this. So here's what I'm going to need to do. Sine of u is -7/25. So I can create a right triangle. If this is my angle u, then I know that this is going to be my opposite over hypotenuse. SOHCAHTOA, right? So this is my opposite is 7. I don't care about the negative signs. We don't need to worry about the negative signs because we know what quadrant I'm working in. We'll worry about that in a second. My hypotenuse is 25. What I need is cosine of u. So if I want cosine of u, I need to know my adjacent over my hypotenuse. And I know my hypotenuse, right? But I don't know my adjacent side. How can I figure out the adjacent side if I have a right triangle? Yeah, Pythagorean theorem, right? So sum a squared plus 7 squared is equal to 25 squared. A squared plus 49 is equal to 625. Subtract 49 from both sides. A squared is equal to 576. Take the square root. Some of you guys might know your Pythagorean triplets too, so you might have already known that A is 24, which is awesome. So this tells me then that it's going to be 24 over 25, but I'm not done. This is the part you guys forget all the time, is that I'm in quadrant 3. So if I'm in quadrant 3 and I'm talking about cosine, tangent's positive, which means this cosine has to be a negative number. So don't forget that. That's the number one thing you guys forget to do. So now I know cosine of u is this negative 24 over 25. But I still need sine of v now. And I have to do that same idea where I know for my v, cosine of v is equal to negative 4/5. So I have to draw another triangle. So here's my v. Again, this is going to be my adjacent over my hypotenuse. So I know that this is 4 and this has to be 5. So I need to figure out what my opposite side is. We want to figure out sine of v. So sine of v is equal to my opposite over my hypotenuse. And don't forget, I'm in quadrant 3. So tangent's positive, which means sine has to be negative. So I already know I have a negative value. Pythagorean theorem. 4 squared plus my opposite side squared is equal to 5 squared. A lot of you guys already know this is a 3, 4, 5 triangle, so I'm not going to spend the time solving that. You guys can do that. So it's negative 3 over 5. So the answer here for sine of v was negative 3 over 5. So when they give me information like this, I'm going to need to make triangles. When they give me values in degrees like this, I can go ahead and break it apart and use my unit circle. So when they give me values like this, whether it's degrees or radians, most likely I think they give you just degrees in here. But that's when I would use my unit circle. When they give me these fractions like this, that's where I'm going to need to make triangles. So you can see the difference in the problems. The formulas are going to be the same. The formulas are the same, but what you use to solve them will be different. So my last step then would be to go ahead and multiply. Negative 24 times a negative 4 is a positive 96. 25 times 5 is 125. A negative and a negative again is going to make it a positive 21 all over 125. Common denominator. So I could go ahead and do 96 plus 21, which is going to give me 117 all over 125. And that is the answer we are looking for. Lot to take in, take it piece by piece and figure out, are you going to need to make triangles to get your values? And don't forget to make sure you pay attention to the quadrant because that will tell you if it's a positive or a negative. or are you going to use your unit circle and pull the values off of it? So this was just the instruction today. I, of course, have problems for the assignment tomorrow. If you guys need help for anything, let me know. And I will go ahead right now. I will send out an image of the unit circle, and I'll also see if I can send an attachment in case you guys want to print it. So whatever method works best for you guys, I'll go ahead and do that right now. Again, if you need anything else, just let me know and I will get back to you guys as soon as possible. You're welcome. You guys have a blessed day today. Bye.
Have a good day.
Thank you. You too.